Hi everyone, welcome to the video. As you can see from the thumbnail, this is part 2 of the MKS video that I released a few weeks ago. So in part 1 we did all the electronics build and tested it. So in this part 2 we're going to cover installing it and then doing the rest of it. So I'll go through what we're going to cover in a minute. Just before we get going on what's in the video, this is going to be the last video of 2020. It's not been a great year for us family-wise. We've lost 2 family members, one through COVID and one through dementia. So it's been a bit of a tough year for us. So hopefully next year is going to be better for us and better for the rest of you guys as well. So and I've had to curtail my flying as well. So because my wife is asthmatic and I can't risk catching anything and bringing it home. So I'm one of the guys at the flying field did get it, COVID, but he survived okay. If you stick around to the end of the video, what I'll do is I'll tell you what we're going to cover next year. I've got a few plans for some different builds next year, and next year is going to be more about actually using the foam cutter, whereas this year's been more to do with building this machine and updating the software and getting it working really well. So so hopefully there might be a few minor updates next year, but that'll be it. So what we're going to cover in this video is how I've installed it on the MKS board on this machine here, and then we're going to look into just checking my notes down and make sure I don't forget anything. So what we're going to do is, once we've covered the installation and the wiring, we're going to then look at the axis direction. That's the most important thing to get right, first of all, making sure each axis is working in the right direction. And it's a common question I get from quite a lot of guys, that they can't get it working the right way. So we'll cover all that. Then what we'll do then is we'll then cover the calibration. So once we've got it working correctly in the right direction, we need to make sure it's moving the right distance then. So if we want it to move 10 millimeters, it moves 10, and not more or less, because I've had a few guys contact me with problems where the model doesn't come out the right size, and that's one potential reason for that. Then once we've done that, if you're not going to be doing homing on the machine using end stops and limit switches, the machine should be more or less working then, and you should be able to go off and start making some parts. If you're going to do homing, then I'm going to cover that section in quite a bit of detail, because there's quite a few things that can potentially go wrong there, and I've got a few ways to make it a little bit easier for you as well. Then once we've done the homing, then what I'm going to do is do a section on the hot wire itself, which is really the crux of the machine. So that's on the hot wire that we use, how we power it, how we can set it up to get good cuts out without burning too much foam away. So that's something called the Kerf value. So I'll show you a way to work that out. And then what we'll do at the end of it, then we'll then actually do a test cut, and just to prove how good the machine is, what we'll do is we'll do a test cut and show you how accurate that is. So what I've done is these test profiles here I've printed off of the machine. I'll then I'll get the drawings out and lay them on top of the drawings, and I think you'll be amazed how accurate it is. I do get a few comments from people saying, how can it be accurate using drawer slice threaded rods and made of MDF? You'll be surprised, and you'll see from the the accuracy as well. So you don't need to spend a fortune on expensive equipment for this. You can get really good results with this machine here, and you should be able to build this machine for sub sort of $200, about £160, or around about 170, 180 euros. So and then what we'll do at the end of the video, if you stick around to the end of the video, I'll tell you what I've got planned for next year. Hopefully I can get back to flying next year, but I'm not going to be attempting to fly until I've had the vaccine, just to be sure. It was meant to be a memorable year this year for, it was our 40th wedding anniversary this year, and it was my wife's 60th birthday. and it was memorable for the loss of 2 family members and not that. So we're hoping next year is going to be much better. But so okay, guys, if you're watching this around about Christmas time, wish you Merry Christmas. So stick around to the end of the video, and I'll tell you what's coming in the new year. So if you watched the part 1 video on the MKS board, you'll have got all your electronics working on the bench, and hopefully now you've got it installed on your machine. So all I've done is I've just changed mine over from using the ramps and Arduino board to using the MKS board, which has been fairly straightforward. Now, as you can see, I haven't got a great deal of space here, so I've mounted the board up on its side out of the way, and I'll go through the wiring with you in a minute. So I'm using the 24-volt power supply, which is mounted underneath the desk here, or bench, because as you can see I haven't got a great deal of room. So what we'll do, we'll have a look how I've wired it up, and as this tower is in the way here, what I'll do is I'll move this out of the way so we can get a better look at the board there. So right, so I think I moved the tower out of the way, and as you can see, I've mounted the MKS board on some 3D printed cases. The base I actually found on Thingiverse, and the top there with the twin fans on it, I actually designed that myself, that one, because there was one on Thingiverse, but it wasn't. It was only for a single fan. So that goes on, and that just sits on with some standoffs, and keeps it cool. And what you'll also see as well, I've used quite a lot of 3D printed cable ties. Now, if you haven't got a 3D printer, you don't have to do it like this. You can do it basically any way you like. The main thing really is to make sure all your cables are secure, and they can't be pulled out, and you get bad connections. There's nothing worse than getting halfway through a cut and then something causes it to stop, and then the wire's just sat in the foam burning away, and you've ruined probably a good piece of foam in a good amount of time as well. So do take a bit of time to check all your connections. Now, on the connecting up to the motors, as I said in part 1 video, these cables we get with them, I think I've seen some 2 meter ones, but I think even 2 meters, they're not going to be long enough, because in my setup here, when it's back in place, I've got about a 700mm gap in the middle. These cables are not going to be long enough to reach these motors. So I have been able to use it on the U-axis there, with the controller being right there, and it goes onto the back there. So I have been able to use that, and you can probably see that. Yeah, that cable is just there, and that goes onto the motor there. But what you'll have to do on the rest of the cables, if you're using the Nema 17s, you'll have to splice into these cables. And then, as you can see on here, I've used a reel of cable I had already, and I've made my own loom up. Now, you're probably better using 4-wire cable for this. It'd probably make a little bit of a neater job, but I had this kicking around, and I thought I might as well use it. But what you need to do is, when you cut into these and splice them, and I've used these strip connector blocks here to join them all up together, what you need to do, and we'll just pull the top off the controller, it just slides onto some screws. And once again, guys, don't forget that fan. If you're going to use 1 or 2 fans, make sure you put a fan on there, because these drivers do get a bit warm, and if you've got a fan going over them, it's going to save you a lot of hassle. So what I've done is I come out with the connector, got into the strip block, and then used the cables, this cable in, and gone all the way to the motor. And then if we have a look at the I'll just turn you around. Yeah, just into there is where the other end of the cable is, and it goes up to the motor. So what you want to do when you've done that is then get a multimeter. Yeah, so what you want to do then is once you've spliced your cables, just get a multimeter, go on to continuity, so that you've got and then check your colours. So we're on the Z-axis here. So if I pull that out there, and then the Z-axis down here, see if I can manage to do this. So if I'm going on to the blue connector there, and the blue connector up there, and just make sure you've got continuity, and do that on each connection. It does take a while, but it's worth doing. And when I was wiring this up, I did find I had a few where I hadn't got continuity, and it was just like, you know, the connections weren't made properly. So it's worth doing that. And then when you power up the machine, when you apply power, what you should find is that all these, I mean at the moment we can turn these threaded rods or lead screws if you're using lead screws. So when you power on the machine, these should all be locked. Now, if for any reason they're not locked and you can turn them, it normally indicates that there's some problem with your wiring. So if that is the case, just go back and double check your wiring. So the power's coming up from under the bench onto these two cables here. So these are a bit, I think these are some silicon wire. I think they're 16 gauge, not 16 gauge, 16 SWG. And then these two here are for the hot wire, which we'll talk about more in the hot wire section. So, and it doesn't matter which way round they go for the hot wire, but these two it does. So make sure you get them right there. Now the other thing that's, while we're in this section here, if you intend to use homing, if you don't use homing, then none of this matters. If you're going to use homing, the number one thing to make sure it's going to work is screen cable. And I'll probably cover this again in the homing section. Make sure you use screen cable, because when I first built this with the ramps board and tried the homing out, I didn't use screen cable. The U, the Z and the X worked fine. The Y didn't. All it did, it just kept going up and up and up. And when I switched over to screen cable, it worked absolutely fine. So, and it's not expensive. This is just 2-core screen cable. So what I've done with that is on the board here, you can see the grey cable come back here, and they go into the various switches. And then this little connector block here is where the screen goes, and that screen then goes all the way back down to the power supply, onto an earth on the power supply. So it's got a good screen on that, and I've had no problems with homing on that at all. But so yeah, we'll discuss that more in the homing section. And while we've got the top off here, if you are doing homing, the connections are quite easy. Basically all I've used is servo connections, you know, for RC. So I only use the signal and ground. Don't use the third pin because the firmware doesn't support it. So we've got the X min there, the Y min there, the Z min there. And the one that's a little bit more difficult is the U. So the U goes onto this pin 42 here, and then onto a ground pin there. So if you set it up using what's called soft limits, then that should work. Don't confuse soft limits with just software. Soft limits still means using switches. You'll see when we get into the homing section. So it does look a little bit of a spaghetti junction, but you know, and there might be better ways of doing it. But I've been running it like this on the ramps board with a similar setup, and it's worked fairly well. It hasn't caused me any problems whatsoever. The machine's been 100% reliable. So I think as far as installation and wiring goes, that's it. And as I said, you don't need to use the 3D printed parts. You can mount it any way you want, but I think a lot of the guys have got 3D printers now, and most of this stuff you can find on Thingiverse and just download it and print it. So it does make for a little bit of a neater installation, and yeah, it's quite good fun 3D printing as well. So that's how I've done mine. It isn't the only way to do it, but just the main things really is to make sure you secure your cables so they can't be moved as the machine's moving. And then if you're using homing, use screen cable, make sure you've got it pure good earth, and check all your connections individually. And then when you power on, make sure your motors are locked, and you should be good to go then. So now we've covered that, we'll get on to the checking the axis direction, which is the most important part as well, and the one where I get quite a few questions as well. So we'll see you in the next section. So the first thing we need to do when we've got the foam cutter powered up is check the axis direction. This is probably one of the most common questions I get from people. They'll build it and say it's going the wrong way and they can't get it go the right way. So there's two ways we can change that. But before we start checking the axis direction, what we need to do is prepare the machine so we don't damage the flexible couplers. So these little couplers here, what can happen is if it's going the wrong way and we tell it to go positive, it doesn't, it goes backwards, it can hit the stops very quickly and it can ruin these couplers. I'll put some pictures up of some I've done. I've done it myself a few times. So what we'll do is we'll turn the threaded rods by hand until we've got some distance away from the stops, and if it does go the wrong way, we can quickly hit the space bar and stop it before it does any damage. Now before you do this, what we need to do, we need to disconnect the motors, because turning these by hand, so as you probably know, a motor, if you turn the motor, it becomes a generator, and it can send current back down into the controller and damage the controller. So what we'll do, first thing is we'll disconnect the motors. I've already disconnected the ones at the back because they're a bit awkward to get to. So as you can see now, we're disconnected on that one, and we're disconnected on that one. And then what I'm going to do is just turn them a little bit. Right, so now you could probably do it a little bit more than that if you wanted to, but now that I've got them away from the stops, we can connect the machine up and start checking the axis direction. So we'll connect the motors back up. What you might have noticed as well is these red supports here on the vertical axis. It's just something I'm trying at the moment. What I have noticed with these flexible couplers, the smaller ones, there is a little bit of movement in them, which there has to be for it to be flexible, and the weight of these can make it sag a little bit. Now on my older foam cutter with the bigger couplers on there, it didn't seem to be too much of a problem, and I never had any problems with accuracy. So I'm just trying it out at the moment. Probably what I'll do is I'll put a link up I'll put them up on Thingiverse. So if you have got a 3D printer, the coupler just slides in, and then it just gives a bit of support at the top and the bottom. And what we want to do on here is make sure you haven't got homing enabled, because even if we are going to use homing, we start off with it disabled. Computer's down here, that's what I'm looking down here. So we'll connect. Yeah, if we had homing enabled, the homing button there would be red, forcing us to home the machine before we could start. So we've got homing disabled. So what I'm going to do is go on to jogging. Now what you want to do is set this to 1mm on the jogging distance, because if you've got it set to 50 or 100 and it goes the wrong way, it does go very quickly. Get ready to just hit the space bar in case anything should go wrong. So what I'm going to do is try on the U axis, and I'm just going to do a U plus on 1mm. It should come forward. Now sometimes what happens with this mouse, and I've had a few guys query this, is if you hold the mouse down too long, it takes us a couple of clicks. You can do it on the keyboard as well, but so we just do it on the switch on here as well. Make sure we've got the motor switched on. So a good check as well, when you switch the motors on, they should all be locked, so you can't turn them. So that's a good indication you've got your wiring correct as well. So if we do, so we're on 1mm, and if we just do a U plus, we should see this axis move. Let's just get you down a little bit. So here we go. And there we are, it did come forward. So what we can do, just to make sure it show it a little bit better, I'll put it onto 10mm now and go U plus. So that's correct. So what we do is we go through and we check each one. So I'll go back to 1, and I know all these are going to be right, so but we'll just do it anyway. So if we do the Z now, and the Z should go up. Yeah, that's gone up. So we'll have a look at the we'll do the Y next. So that should go up. And then what we'll do is we'll do the X. So that should come forward. And they all do. So that's all working great. Now, if you find one of them's going the wrong way, there's two ways we can do this. We can either do it mechanically, or we can do it, well, not mechanically, electrically, or we can do it in software. Now some guys have struggled a little bit doing it in the software, but I've got a method here that makes it a little bit easier. But what you can do, and I'll put some pictures up, you can actually on the ramps board and on the MKS board, you can actually take the connector off where it goes onto the board and just reverse it and put it back on, and then that will make it go the other way. Now on the MKS board, it's got like a plastic shroud that will only allow it to go on one way, but if you're very careful, you can pull that off, turn it around and put it back on. But it is quite easy to do it in software, so as you've got it all wired up, it's probably best to leave it as it is. If you're using the bigger Nema 23 stepper motors and you want to reverse it, you can do a similar thing there as well. All you need to do is reverse the connections on the external driver where the A plus, A minus, B plus and B minus go in, and just swap them round and it will go the other way as well. So that's one way you can do it. The other way to do it, And what I'll do is I'll set this up so it's all going the wrong way. The way to do this, if it's all going wrong, we'll set it, and I think this is the simplest way to do it. We'll just go into the software and we'll just set it to 0. And with it on 0, none of them should be inverted. So we'll go on to $3 there, and we'll put 0 in, and we'll hit return. Make sure you hit return as it doesn't like it. And then sometimes it takes a setting, sometimes it doesn't, so always disconnect and reconnect, and then we'll make sure we're on 1mm. And then what we'll do, we'll just write the axes down as it is in the table. Get back to the page. So we've got X, Y, Z and U, and I'll just put a yes there, yes to invert. And then what we're going to do now, we're going to check each axis again. So go back onto the software. So we're on 1mm again. So I'm going to check U now, and we'll see what happens on the U. So if we need to invert it, we'll put a Y in there. If we don't, we'll put an N. So we'll see what happens on U. So we're expecting it to come forward. No, and it's gone back. So what we need to do, yes, we do need to invert U. So let's try Z now. So if we hit, so we're still at 1mm, if we try Z, that's working okay, so that's going up. So on Z, no, we don't need to invert it. So let's go and have a look at the X and Y. So if we try X now, and X has gone back instead of forward, so we do need to invert the X, and you can probably see what's coming next. And we'll try Y now. And Y is okay, so we don't need to invert. I'll hit the mouse key. So what we've got there, we've got, so you can see that, get a bit close. So what we've got is we need to invert the X, we don't need to invert Y, we don't need to invert Z, and we need to invert U. So if we have a look for that pattern in the chart, go back onto the computer, and we have a look at that pattern on the chart there, and if we go down, and if we look at 9, so 9 corresponds to the pattern we've got, so we've got Y, N, N, Y. So what we need to do, we need to put 9 in the $3 setting. So go into settings, $3, put 9 in that, and then just as a precaution we'll disconnect and connect. So what we should see now, so we're on 1, so if we go onto the U, so if we go on to U, and we're on 1mm, should come forward, and it does. We'll just do it a couple of times. So yeah, so that's coming forward. So if we go on to Z, that should have been right anyway, but just in case you got your numbers wrong, it's a good idea to check them anyway. So Z's okay. So if we go back to these two, so X, so if we go X plus, we'll do it a couple of times, that's right. And then if we do Y plus, and that's all okay. So we now know the machine's working in the correct directions. So once we go on to doing homing, if you're going to do homing, we know everything's working right. You can't do anything with this machine really until you get the directions correct. So I hope that's a little bit easier to do if you're going to do it in the software. Personally, I think the software is the easiest way to do it rather than messing around with cables and swapping things around. But I know some guys, they're not very au fait with the setting side of things. So hopefully you've got everything working in the right direction, and we can move on to the next part, which is calibration. So we've got it working in the right direction. Now we need to make sure it moves the right distance. So we'll see in the next part. So now we've got all our axes working in the correct direction. What we need to do now is go on to and check the calibration. Now if you've built the foam cutter exactly as it is on the website, using all the recommended parts the same as mine, the settings in the firmware will probably be almost spot on, or may need some minor tweaking. So when I say the settings, when we're looking at calibration, we're looking at the steps per millimeter setting. So in the firmware, it's set up for this machine, but I know a lot of you guys have decided to use lead screws, or I know some of the guys in the States have trouble getting the 10mm by 1.5 pitch threaded rods. So what we need to do then is check the calibration, and the reason for doing that is to make sure that when we tell the foam cutter via the G code to move a certain distance, it actually moves that distance. So if we say to it, you know, move 10mm, it's going to go 10mm and not more or less. I've had a few guys contact me and they've designed their models, and what's happened is they've not come out of the correct size, and this is probably the main reason why that happens. So what we need to do is check the calibration and make sure it's accurate, and then we'll get accurate models out. You'll see what we'll do is when we do the test cut, well, I've actually printed out the profile of the cut we're going to do, and what we'll do is we'll try the actual cut on the printed profile to see how accurate it is. So that'll give us a good indication of how good it is as well. So the way to do the calibration, as you can see here, I've got the GoPro on the Gorilla Pod over a steel rule here, and this steel rule, I've screwed it down to the bench there so it doesn't move, and there's just a piece of wood there just to support it. And all I've done is I've created a pointer that's on the carriage, and all it is a large paper clip that I've bent, and I've lined that up with 300 on this steel rule. So what we're going to do, we're going to tell the foam cutter to move a certain distance, and then we're going to check to see how accurate it is. Now, if for any reason it's not moving the distance, what we need to do then is calibrate the steps per millimeter. Now on the website, bring up the website here, there's a page called Calibrating the Foam Cutter, and if you go down, there's a section there called Check the Steps per Millimeter, and I've given some example ones there that are pretty close that you can try and use if you're not using the 10.1.5s. And it tells you how to do it, and then at the bottom here there's a little calculator. So what we do, we put the current steps per millimeter in. If you just downloaded the firmware, that figure 1066 will be the correct figure. Then we put in the distance we requested it to move, and then the distance it's actually moved. And what happens then? So if we asked it to move 150 millimeters and it only moves 148, we put them figures in and it would give us a new figure for the steps per millimeter. And then what we would do then, we'll go into the foam cutter, into the settings page, and we'll put that in. So what I'm going to do first of all, show you how it works. And mine's set up so it's actually correct, but what I'll do is I'll alter it and so it's not right, and then show you how we can correct that. So what we need to do, bring the foam cutter up, bring the foam cutter software up, sorry, then connect. And we haven't got homing enabled on this. We don't want homing enabled yet. I mean, if you're not going to use homing, then that doesn't matter anyway. And what we're going to do, we're going to use this manual command in here. I'll just switch the motors on, so I've got the motors switched off at the moment. And then if you look on the page, it tells you what we need to do there. If I can find it, here we go. So in the manual command display, what we do is we type G0, U100 and F50. So what that means, G0 is what's called rapid move. The U100, so U is the axis, and then we're telling it how far we want it to move. So this example here, I've put 100, and then we're giving it a feed rate to go. Right, so what I've done, I've purposely set the steps per millimeter wrong. So if we look in settings, on the U axis I've put in 1071 instead of 1066. And what I'm going to do is tell it to move 200 millimeters, because the bigger the distance you can give it, the more accuracy you're going to get. So the command I've got in is G0, U200. I don't think the feed rate matters on G0. It's got a set. So we'll give it send and see where it comes to. So we're expecting it to end up on 100. See, the wire's getting a bit closer. And you can see it's just gone over. So if I just get you in for a closer shot. I'm not sure if you can see that with the light that's shining on. But to me it looks like it's just gone over. So what we do then, we go onto the website. So the current steps per millimeter is 1071, which is from our settings there on the U-axis, $103. We requested it to move 200, but it actually moved 201. And then you can see at the bottom now, it says 1066. So I have tried this with smaller distances, and you don't seem to get the accuracy with smaller distances. So I would, after doing this for a while now, I would suggest you do at least 200 millimeters, probably more if you can. So what we would do now is so we'll send the carriage back before we change it. So we'll tell it to go back to 0. So we can do it on the command line here, be a bit quicker. Go to 0. So it should end up back on 0, I'm hoping. Just get rid of the space bar in case for any reason it carries on. When I say 0, it's on the 300 actually, that's what I mean by 0. So what we'll do now, we'll go into settings, we'll go on to $103, change that to 1066 and hit enter. And what I found with this, sometimes it takes this setting, sometimes it doesn't. So it's always best to disconnect, reconnect, and then what we'll do, I don't think you need to put the F command in because it remembers the last one it used. So we'll just go G0 U200. So if that's spot on 300, we should end up on 100, fingers crossed. That looks pretty spot on to me. That was lucky. Not lucky really, but it's when you do these things, you know, on YouTube, and you always hope they go right, but quite often they don't for whatever reason. But yeah, so that's our calibration set. You only need to really do this on one axis because we're using the same threaded rods or lead screws. We can just put the same setting in them all. So if you look on the settings here, on $100 to 103, they've all got exactly the same settings. So now that we know our calibration is correct, then we can go on and we should get accurate models out it now. Now, if you're not going to be doing any homing, so you're not going to use homing switches or anything, then that's the machine calibrated and ready to go. But in the next section, what we'll do is we'll go on and we'll show you how to set up homing. You don't need homing. It's a nice to have feature. I quite like having it because you know where the machine's starting from. But if you don't have it, as soon as you power on the machine, as you can see here, we've got homing disabled, which is $22. So homing is disabled at the moment because it's set to 0. Wherever you power the machine up, that's taken us to 0 position. So that's it for the calibration. As you can see, it's not too difficult now. When I first did this, I didn't have the calculator on the website. So you can see with the calculator, it does make things a bit easier for you. And what you would do is, if it wasn't quite right when you did that, just go back and do it again and do it a number of times. But the thing to remember about this is that with a foam cutter, we're not looking for the accuracy of like a CNC router or milling machine to a thousandth of an inch. You know, if we can get to within, you know, half a millimetre on a piece of foam, I mean, you know, that's going to be more than good enough. And I've run some tests earlier, and I'll show you that the accuracy is very, very good, even with these draw slides, threaded rods. You know, some guys do put comments on, say, oh, it will never be accurate. You'd be surprised. So we'll see that on the test cut. But what we'll do now is we'll go on to how to set up homing. So in this next section, we're going to have a look at homing. And so what homing does, it sets the machine up to a known 0 position. So the axis, the Z, the U, the X and the Y, a known 0 position. Now, there's two ways you can do this. You can do it either with switches, which we're going to cover in a minute, or you don't have any switches at all, and as soon as you switch the machine on and connect, that's its 0, 0 position. Now some guys use that and that they have no need for having extra switches. But it is a nice feature to have on the machine. So we'll show you how to set it up. So there's two ways to do it with switches. I've taken the slightly easier route. So what I'll do, I'll show you how to do that. But I'll also show you how you could do the other option as well, which involves a lot more wiring, which is why I haven't gone that route. So I do get quite a lot of questions on homing, and it can be a little bit tricky to set up. And one of the reasons for that is that some of the terminology isn't that great. There can be a little confusion with things like hard limits and soft limits, and I've had a few guys that have, got confused over that, and admittedly, when I first started, it confused me a little bit as well. So it's easily done. If you've watched part 1 video, I was showing you where we connect the homing switches up, very briefly. But what I'll do, I'll put another diagram up and show you where we connect it. Now on the MKS board, it uses the same pin numbers as the ramps board, but they're just in different positions. So if you have a look at the diagram I'm putting up now, you can see where they go. Now make sure you only use the signal and ground. Don't use the third pin. This firmware doesn't support that, so you could end up damaging something if you do that. The other thing to do as well is make sure we use screen cable. Now screen cable, we've got the 2 wires that we use for the switch, and then there's a screen goes around the outside. And the reason for that is these little motors with the magnets in them, they can induce voltages into the wire and cause spurious signals. And when I first set this up, I tried it without using screen cable, and 3 axes worked fine. But then the y-axis, all it did is, instead of homing, it just kept going higher and higher and higher. And so when I purchased some screen cable and put it on, it all worked perfectly. So don't try and skimp on the screen cable, because I think you'll probably find that you will get problems, and it's one of the most common issues with homing. So make sure you've got your screen cable first. And I've still got all this left from what I bought to wire this machine up. So and it's quite cheap, so it's not worth skimping on that. And the other thing I've used is I've just used standard micro switches, as you can see there, and I've printed these 3D brackets here, 3D printed brackets. Now you don't have to do that. You can put the switches on any way you want. And on my old machine, I just had a couple of small screws that used to just screw them in onto the various parts of the machine. By using these 3D printed brackets, that there's a bit of adjustment in them as well. And all I do is I put them on. You can see the switch just slides on, and then all I do is put a little dab of hot glue. I'll show you in a minute when we have a little bit of closer look. And I've got these on Thingiverse, so if you want to use this method, by all means, and if you've got a 3D printer, of course, then you can just download them and print them. And so far they've worked really well. What we'll do in the next section, I'll actually demonstrate homing, because if you've never seen it working, you might be surprised how it works. So what we'll do in the next bit, we'll actually demonstrate homing working. Then we'll go on to how to configure it, what to do if it doesn't work properly. The most common thing is that when you home, the axis goes the wrong way. Instead of homing, it's going further away from the homing switch. So we'll look at that in the next section. Right, so what I'll do now is demonstrate homing. And as you can see, we've powered up the machine, and on the DROs, the computer's just down here, but you should be able to see it with the screen capture. So we're showing -10 on the big numbers here. The big numbers are called work coordinates, and the smaller numbers here are actually machine coordinates. So the machine coordinates will never change. It's actually the limits of the machine. So from 0 to how far it will go. So what we want to do before we start a new job, we need to home it. Now as you can see, there's a red on the homing cycle there. So until we've got that clear and it says idle in the corner there, we can't start a new job. So what we do, we'll just set it to home. And what it does, first of all, it starts the Z-axis, and then it does the U-axis, and then it will come over to this side, do the X, and then the Y. And then when it's finished, what you'll see is all the DROs, digital readouts, all go to 0, and we're now at idle. So we're now ready to start a new job. Now probably what you want to do, you won't probably want to start the job with the wire right down there. So what I normally do is I normally have a piece of foam and then the job on top. So what we would do then was we would then bring the, so let's go up 10. So now you can see the machine coordinates and the work coordinates are exactly the same on 10. But what I'm going to do now, so this is assuming the position I'm going to put my piece of foam to start cutting. And all I'm going to do now is 0. And so when I start the G code running, that's where it will start from, its 0, 0 position. Now the other thing we're going to be setting up is that the configuration we're going to use is called normally closed. So it's generally recommended to be the best way with switches, homing switches, or end stops as they're sometimes called. So what happens is these switches are closed, and then when the axis comes up and touches the switch, it breaks the connection. The reason for that is if there was a problem, and I've had it once or twice on here with some loose connections, if there's a problem, it assumes that it's homed and it won't go any further. So I've had a couple of times where I've had problems with the Y-axis with a bad connection, and it starts homing and it just stops. Now if you have it normally open and you've got a bad connection, you don't know when that's going to happen. So I've always wired my machines up with normally closed switches, and that's the settings we'll be using. So what we'll do then is we'll go in and we'll show you how to set it up. And it's quite easy. The most common problem you'll get is that instead of the axis homing, it will go the wrong way. So you'll set it to home and the axis will move wrong. So we'll go into the configuration now and show you how it's done. So what we'll do now is we'll have a look at how to actually configure homing. Now this is all documented on the website and in the ebook, so I highly recommend you go and have a look at that first. And there's a whole section there, and I'll put links in the description of the video on all the settings. Now before you even attempt to start doing any configuration of homing, make sure the rest of the machine's working correctly. So don't try and do this unless if your axis is not going in the right direction and you haven't calibrated it properly. Make sure everything's working first before. This should be the last thing you do, in the build of your machine. So if we go down and have a look at the settings, there's quite a few settings. So one of the decisions you need to make before you start to think about doing homing with switches is how you're going to do it. Now there's two ways to do it, and I've put a diagram up here. And we've got soft limits and hard limits. Now you'd naturally think soft limits wouldn't involve any hardware, but it does. Basically what the difference is, if we look on the diagram here, on soft limits we have one switch at the minimum setting, and then we tell the software how far it can travel. Whereas hard limits, we have a switch at the minimum end and a switch at the maximum of travel. Now, there's advantages and disadvantages to both of them. The main disadvantage to hard limits is you've got double the wiring. So you're going to have eight switches. So on my old foam cutter where I was using Mac 3 and Linux CNC, I did have switches at both ends. And I was forever tracing down connection problems because the thing's moving a lot. And what I found is that I never triggered the maximum switches. So on this machine here, I've decided to go with soft limits. So that's why we only got one switch on the axis. And then what we do is within the software, we set how far it can travel. So we can work out how far it can travel just by jogging the machine until it gets to its maximum, and then just note that down. So what we need to do, first thing to do is to enable homing. And we enable homing by setting $22. So if we go into the software, on the settings tab, and if we scroll down there, we can see $22 is enabled for homing. When we, as you remember, when we first did the axis checks that work in the direction, even when we were considering using homing, we disabled homing anyway, because to start with, it gets in the way, it tries to home, and if we haven't got it configured properly, then it will just get into a mess. So when we first build the machine, we set $22 to 0. Now we're ready to set it to 1. So we set it to 1, and then the other settings that we've got, now to set it up as like I've got it with soft limits, we set $20 equal to 1. So if we go into the settings there, and we see we've got $20 there, set to 1, so that's soft limits. As I say, the terms are a little bit confusing because you think soft limits does involve hardware, but it involves switches. And then these other settings here, the main one we need to use with soft limits is $130 to $133, and that sets the maximum distance the software can move. So what happens once it's homed, once we've got our calibration correct, that's why we need to get it calibrated properly. It will then travel that distance, and once it gets there, it won't travel any further. So make sure you know how far your machine's going to. So if you've built it exactly the same as this, I've got roughly about, let me just see what my settings are. Can't remember off the top of my head. Yeah, so I've got 400 millimeters on the vertical axis and 600 millimeters on the horizontal axis. Now, if you haven't got them set, what will happen as soon as you try and home, all it'll do is just stop. I found that out the hard way. And then once we've enabled homing, what we need to do on the machine then is check that our switches are triggering properly, and that's quite easy as well. If we go onto the settings page, we've got limit switch status. Now what we want to do is check each switch. Let me just grab a screwdriver. See if I can get to them easily. So if we watch on the screen there, I'm going to trigger the Z switch. So if I just trigger Z, get my arm out of the way, so you can see the Z coming on. So what you need to do is to make sure that all your switches are triggering. So if I just reach around and feel. Yeah, there we are. Got X trigger in there. Y trigger in there. And then if I just get over there. And trigger the U. So make sure that they're working now. If for some reason they're not working, check on the pin outs. So on the MKS board we need to use these pins here. So we're only using min. Now if you're going to use double switches, then you're going to have to use, so if you're going to use a max setting as well, then you would use the one next to the X there on them 2 pins. I'd advise you that you don't do it that way. It just has a lot more wiring, and I think in the end you'll thank me for it anyway, because you'll be tracing connections all the time. So the Y's quite easy and the Z's quite easy, but to do the U, if we have a look at this diagram here, you can see that we're having to use these pins here. So it's actually pin D42, and then we need to ground the other side on D. I'm not sure that actually, yeah, it's just a ground pin, that pin there. So that's how we get the U working. Now on my setup there, I've just not used servo connections and just taken one of the wires out and use them, and then just pinned onto the. I'll put a picture up of it so you can see that as well. It's not easy to see on the machine, especially with the lighting situation in here. So that's how you need to wire it, and then go on to the limit switch status there and check they're all triggering. If they're not triggering, it's never going to work. So make sure they're all triggering. Some of the other settings as well. $27 is the axis pull off. So what that means is when the it homes, how far it will come off the switch. I'm not sure what mine is. I don't think mine's very much, probably a couple of millimetre. So $27. Yeah, I've got 2 millimeters for $27. Now when you've got soft limits, don't enable hard limits. So if we go down to the diagram there, and vice versa, if you're going to use hard limits, don't have anything in $130 to $133 either. The other setting that you might need to use, but I haven't had to change it at all, is something called debounce. So what's that's to do with is when the switch triggers, when it comes back off the switch, sometimes they don't make a real clean connection. You can get a little bit of arcing across the switch, and sometimes that can confuse it. So you can put a debounce setting in there. I had that on my original foam cutter when I was using Mac 3. And it was doing some strange things, and I posted them on one of the forums, and the guy came back very quickly and said, just increase the debounce, and I did that, and it worked perfectly afterwards. So if you do find funny things happening after it's triggered the switch, just try increasing the debounce value. So I think mine's at default, I think. So that's $26, 250, so that's 250 milliseconds, I think. So the next one I get quite a lot of questions about is homing. It goes in the wrong direction. So when you set it to home, instead of going down towards the switch, it goes the opposite way. So what I'm going to do in the next section, I'll show you what to do if it goes wrong. I'll purposely set it wrong, and then we'll go into it and show you how to do it. I think it's a little bit simpler way of doing it as well. So I've purposely set the machine up so it will home in the wrong direction, and show you how we change that. So it's ready to home now. So if you watch what happens, so Z's okay, U's okay, X is okay. If you see what's happening now, the wire's just going in the wrong direction. So what we have to do, if we just press reset to stop it, and then if we go and look on the settings tab, we've currently got a value of 13 for $1.23. So if we look at the table and go down to 13, and this second column is our Y, so Y is going in the wrong direction, so all we need to do is change that value to a Y. So what we want is, for this setup, we want all these values to be Y's. So if we look down here, Y is on 15. So if we go on to 15, we go back onto the machine, go to $1.23, change that to 15. We've got 5 there, haven't we? And make sure you hit enter after that, because it doesn't take it. So what should happen now, it should probably say now it wants to home again. So if we now run a homing cycle, so X is, so Z's okay, U's okay, X is okay, and now hopefully Y should go down now, which it does. And it went up quite a bit. It would have gone on forever until it hit the top. Isn't it? So just to recap on that, so all we need to do, whichever axis you find going wrong, look at the value you've got in the settings. So in $1.23 we've got a value of 15 now. So if we found that was wrong, so if we found X was going the wrong way, we've got a value of 15 in the settings. So that means that we need to invert whatever the X is on. So this first column is X. So what we need to do is look up through where, actually it's the one above it. So if we needed to invert the X, we would just go up to this 14. So that would leave them the same, and 40. It's not the simplest thing to do, but you know, if a little bit of patience, and you should get there. So just look at the value you've got and see what it corresponds to, and then see which axis you need to change. And you might have to do it step by step. So if you found the Z-axis was wrong to start with, the first one it starts with, you might have to go and change that, and then when it goes on to the next one. So it might take you 3 or 4 goes to get them all right, but you will get there in the end. So that's about it on homing, really. There's not much else. So main things really, make sure your switches are triggering. So test them to make sure they're triggering. Make sure you use screen cable, and if you are going to use hard limits, so if you are going to use hard limits, you're going to need to put more switches in. And with soft limits, all you need to do is go into $1.30 to $1.33, and then put your travel in. So you can work that out by just jogging as far as it will go, and then see what values you've got. So hopefully that should get your homing working, and if you do get stuck with it, just drop us a line either through the website or in the YouTube comments, and I'll take a look. Right, in this section we're going to cover the hot wire, which is really the whole basis of the machine. So it's controlling this hot wire we have across the back there that's going to make our foam parts. So we need to have good control of that, otherwise we're not going to get the parts out that we intended. So what we're going to have a look at is where it's connected, the type of wire. We're going to look at the settings tab on the software. Then we're going to look at the slider, how we set it. And then what we're going to do then is go in and show you how to try and ascertain what the kerf settings are. Now the kerf setting is how much foam that's melted away. So just as a little example here on this test aerofoil I was doing, it's how much of the foam is going to be melted away. Now if we don't get that right, what can happen, you can end up burning too much foam away, and when you get down towards the trailing edge there, sometimes if you've got the wire too hot, it will just burn it away completely. So we need to get a good setting. So we'll go on to that as the last part of this little section. So first thing to do is connect the hot wire. Now I don't know whether I can show you this very well. So we'll start off by showing you where the hot wire is connected, and on the MKS board, as you can see up here, it's connected on this connector here, and this connector is called D8, and all you do is you put 2 wires into there. Just make sure they're a reasonable size of wire, so you can supply the current. In all my foam cutting, I mean, I haven't got a massive distance here, but I've never used more than about 2 to 3 amps. So it doesn't need to be a massive cable, but if your machine is going to be a lot bigger, it might be a bit more. Now the thing is, because on this MKS board, I'm using a 24 volt power supply, which, as I said previously, is mounted underneath to save space. So when you go up on your voltage, you go down on your current. So we're not actually needing as much current on this wire now. And you'll see when we go into the settings, and I'll tell you what the differences are from the 12 volt supply. So all I've done is I've connected it into the D8 connector on 2 wires, and those 2 wires come down onto these crocodile clips and then connect to the wire. Now this wire is 0.4 millimeters, and it's actually something called Litz wire. There's quite a few different wires you can use. The only reason I've used it is somebody gave me this wire many years ago, and I thought I'd just try it, and it works really well. So, but there are other you can use nichrome wire, and a lot of guys as well use something called Rene wire. I think that's R-E-N-E, and they have good results with that. So even in the past, when I was testing, I've even used guitar strings. You know, before my son moved out, you know, he was into guitars like most young lads are, and when he discarded his old guitar strings, I tried a couple, and they do work, but you only want the very thin ones. So the other thing to do is how we're going to tension the wire. So the wire goes around this little collet. This is actually an axle collet from an RC plane, and then what happens then? I've got some strong fishing wire there, and this fishing wire goes up to this spring, and that spring is then connected to the draw slide. There's a little bit of tension on there, but there's nothing. It's not really tight. Now some guys, rather than do that, what they do is they use a bow, and what they'll have is they'll have a couple of brackets, and I'll put a picture up to show you one. A guy in the States, Nathan, he uses that method, and you have a couple of brackets on there, and the bow sits on there, and all the tension is on the bow. But what you have to do, the bow, you have to support the top of it so it doesn't fall over. So quite a few guys use that. I think if I use that method here, I'd be, because of my limited space, I'd be stuck for space for using that. But it has something I've considered using in the past as well, but I haven't actually tried it. But that's another good method. So that's how I use mine. So it's got a spring there on some fishing wire. If you have the spring down at the bottom down there, if you're making small pieces, that's okay. But what happens is if you're doing a tapered wing, and you find that one carriage moves a lot further than the other, then the spring can pull out quite a way, and you might find yourself stuck for distance there. So that's the reason I put my spring up there out the way, and by doing that, it means I get more distance there on the wire. And I've used that method for some time, and it works quite well. So that's how it's connected, and how I tension it, and the type of wire we use. And the other thing to do is just make sure your cables are long enough, so when the carriages move, it's got enough distance. Nothing worse than getting through a cut and then your cable comes off. I've done it in the early days, and yeah, it's really annoying. So now we've got the wire on there, we've got it tensioned. Then we want to know how we're going to supply the power to it. Now there's two ways you can do it, and in the past on some of my earlier videos you might have seen I used the iCharger, but on the last release of the software, or the last video, I went into looking into how to get the control working better, and I found there was a little bit of a bug in the software, the first one I released, and since trying that, and I'll link you to that video, show you how it all works, but it does work a lot better now. And so far I've been using the power from the either the ramps board or the on the Mega. So even though we're talking about the MKS board here, everything here it works exactly the same for the ramps board as well. So the only difference is we're running 24 volts here instead of 12 volts on the ramps board. So if we go onto the computer, and I'm connected here, if we look at settings, we've got, you see I've got ramps input voltage there. Probably need to update that, and so it includes MKS as well. But we've got input voltage and start at. Now the input voltage, it doesn't alter the amount of power that's going to the wire. All that input voltage is for, if we go back to the interface, all it is this slider here, it's to scale it correctly. So if we're using a ramps board with 12 volts, as we move up, it's in divisions of 12 rather than in divisions of 24. So that way you can get a better control of your wire. So, and the other setting we've got there, we've got a setting there that says start at. Now once you've found a good setting for your wire, what you can do is put that setting in, and then as soon as you start the machine up, it's already set there. Because what I found on the original release is I'd find a good setting, I'd written it down somewhere, and I couldn't remember whether I'd written it down or what it was. So that came out on one of the first updates I did to the. So yeah, once you find your ideal setting, you can put it in there. So as I said, that setting there doesn't make any difference to the current that's going to the wire. The only thing that makes a difference to the current going to the wire is where this slider is. So you can move this slider up, and there are some controls, and if you just hover over it there, you can see page up and page down goes up and down by 10%. So I found this works really well now, and it's a lot easier. So what we'll have a look at next is how we get a good kerf setting for our foam. So I'll show you the method I use, and it seems to work fairly well, and it's really taken from the early days when I was using Profili Pro software, and there was some help in there. If you're trying to get accurate parts out, you need to know what the kerf value is. So that's the thickness of the wire plus the amount of foam that's been melted away. And if you've got that in there, and you know, especially on Dev Fuzz foam too, the wings come out very accurate. And when we go into the test cut, you'll see that. I've done a few already, and you know, I knew it was good, but I'd forgotten how good it was. So next section we'll go on to looking at the actual kerf itself, how we can ascertain that. Right, so in this section we're going to see how we can get a good kerf value to put into our software so we get accurate parts. Now the way I do it is use some scrap foam, and what I do is I get the foam and a pair of calipers, something that's reasonably accurate to measure, and then just measure the foam. Don't press too hard, because this will it'll squash it. So if you can see there, we've got a, you see that reading there? We've got a reading of 49.78. So what I do then, I'll just write that on the foam, and also make a note of it. .4978, so this is in millimeters. Then on the foam, I'll then place it on, and I've already pre-adjusted the wire just above this block of foam here, and it's set to 0. So all we do, so what I'm going to do is line it up. Doesn't have to be too accurate, this, because we're just using some scrap foam. There's a couple of weights on here just to stop the foam block from moving. And then if we have a look on the software, you can see there's a setting there called macros, and there's one there I've created called Kerf, and I'll put this on the website. Basically all it is a little bit of G code. So if we double click it, and you see on the G code there, basically all it's doing, it's moving the U and the X axis forward. So how far have I got it moving forward? I've just got it coming forward 40 millimeters. And then once it's done that, it will go back. And then once that's come into the foam, what I'll do then is then cut the foam. So I've got the two pieces, you'll see as we do it, and then measure the distance again. So I'll just show you how it works. So we'll switch the power on. So we'll go to interface. So at the moment I've got it set at 2.4 volts there. So what we're looking for, when the wire is going into the foam, it wants to be coming into the foam without dragging. So if you can see the wires being bent, it means we haven't got enough current. But conversely, what you want to make sure is we're not getting massive burn away. So we've got too much current. So what we want to do is we get the current that's coming through the foam, where the wire's not being distorted, and it's not burning too much away. So what I'll do is I'll set the wire on at 2.4. Sometimes you can just hear it buzz a little bit as well. And what I like to do is I'll just double check to make sure it's getting warm. Yeah, it's going through there. And then that macro there, once you've created that macro, all you have to do is give it a name, put the settings in the G code, and then when you go onto the interface, it will appear down here with whatever name you've given it. And all we have to do is click on that. Let's just make sure we can see that okay. Get a little bit closer in. And all we do is we run that macro. And you can see as it's coming through the wire there. So you can see as it's coming through the foam there, it's burning a little bit away, but not a massive amount. And if we look at the wire, if we look down over the top, you see the wire wasn't being distorted. And then once it's done, it then goes out back out to where it started. There we go. And we'll switch the wire off. And I'll just switch the power off to the machine. I tend to switch the power off because it means that the motors are not running, and so as long as you don't turn any of this, you'll be fine. You know, turn any of it by hand, and it just means the motors are not constantly powered. On some softwares, there is an option to disable the motors, and I think there is one on this firmware, but it's something I haven't looked into. Maybe next year might look into that. Right, so what we do now, once we've got that cut, so if you have a look there now, it looks, what's it look like under there? That looks quite a nice cut going through there. It's not burnt too much away. So what we'll do now, I'll just nip over to the bandsaw, and all I'm going to do, I'm just going to cut it so we end up with two pieces, and then what I'm going to do, put them together and measure it, and that should give me the distance, a new distance there, and we can subtract that from the original value and see what the actual kerf value is. So 2 minutes. So there we go, I've just cut that piece off. And what I tend to do as well on these pieces, just for future reference, I put down the settings. So we was on 2.4. So I just put the setting up on the phone there. So if you're doing a few of these, you can go back and check. And so what we'll do now, what we'll do is we'll now measure it. Try and measure it the same way we measured it before. So we have a look now, we've got 48.13. Let's just check it in a couple of places just to make sure. 48.25, 48.15. I say as an average, 48.2. 1.8, we'll call it 0.2. And then all we do then, so if we put that so if we take 48, excuse my scruffy writing, but if we take 48.18 from 49.78, we end up with 1.6. So at that current setting, 2.4, we'd want a kerf value of 1.6 millimeters. So in whatever software you're using, we can put that value in. CNC Foam has some settings in there, and it also has something called Smart Kerf as well. So when you're doing tapered wings, what you'll find is that because one end you've got a small tip and you've got a large root, the wire at this end isn't moving as fast than on the root. So you generate a lot more heat on this end, and it can you can end up with a wing a lot smaller. But with CNC Foam, it has a setting to compensate for that called Smart Kerf. So you put in your wire setting, you put in your nominal kerf value, which we found here was 1.6, and then when you tell it to use Smart Kerf, it will work out a setting that should give you a good. I mean, it's not 100% perfect, and you might have to tweak it a bit, but it gets you pretty close, and I've had some good results with that. So what we need to do then is try different values, and you can see on here, I've been testing this before, and I've got some that I've done at 2.2, and some I've done at 2.6. And through testing, I found with this setup here, with this length of wire, That's about right. That's one thing I should mention really, that the length of the wire will make a difference to how much current you need to put into it. So if you imagine if this was a lot longer, to get it to the same temperature, you're going to have to put more current in it. So it's not an exact science, and you will have to do some testing and keep lots of scrap bits of foam. I tend to use the foam for testing that I'm going to make the model out of, because what I have found in the past, I used to keep all sorts of bits of foam. So what I found is that even on polystyrene foam, there's lots of different types, and some are a lot denser than others, and they take different amounts of current. So when you've made a model with your foam, keep any bits that are left over. You can see like here, I've got, this was a bit for testing, so I keep all these bits for testing and make sure I've got the good current value. And it's also a good idea as well, because you see here we've only done a small width here. It's a good idea as well to try and do it that way, because sometimes what you can find is as the wire comes into a wide piece of foam, the foam itself can draw a bit more heat out of it, so you might need to just up the current a little bit as well. So it's worth testing it long ways as well as that way, you know, on the type of, so if you're going to make a wing that was that distance, probably as well to get a scrap piece, put it up on your wire and run that test again just to make sure you've got it right. Because I found that sometimes is when you test on a small piece, it's you get a setting, and then when you put a big piece of foam in there, the foam does tend to take more heat out of it, and it can start to drag a little bit. So that's why it's good to do a test long ways. So hopefully that'll get you going on the kerf value. So if you can get a good kerf value, you should be able to get some good parts out of your machine. I've seen quite a few videos on YouTube, and when you watch people cutting foam with a wire, you can see it's burning a massive amount of foam away. And that's fine if you're doing a very simple shape, but when you've got a shape, something like that, and you're burning loads of foam away, you'll end up with nothing on something like that, you know, if you're doing something small. And as you can see on these here, we can get some quite intricate pieces if we've got the kerf value right. So hopefully guys, that will get you going. It does take practice, and I'm still no expert at it. I still have mistakes, and you know, when I first started doing this on my old foam cutter, I bought an 8 foot by 4 foot sheet of polystyrene, like this white stuff here, and I never got anything out of it. By the time I'd been testing, all I had was loads of bits, but it was, even though I'd got nothing from it in the way of a model or a wing, it was good experience. And then once I'd done that, I then went on to make you know, quite a few flying wings. There's my Hawker Hurricane, which you've probably seen on the website, and I've done loads of wings, and then there was the BAE Hawk as well. So it was all good practice for them. But yeah, so don't expect to get it right first time, and don't be disappointed if it doesn't come out right first time, because you will get there. It just takes a bit of time and practice, like most things. So what we'll do now is we'll go on and actually look at a real test cut and show you how accurate that can be. So in this section, we're actually going to do a test cut. So as you can see, I've got the foam set up on a foam block just to raise it up a little bit, and it's on with some double-sided tape. And all I'm doing here is changing to the correct profile. So this is a 250mm Clark wire aerofoil with a 4mm spar. So we'll just set the wire going, and I'm just testing it just to make sure it's getting warm. And then what we'll do then is, once we're okay with that, we'll just set it going with the run command there. So we'll set it going, and then we're looking from the side now as the wire's coming up. So I'm not going to make you watch the whole of this. Once we get going, it speeds up quite a bit. So here we go now. So this is running about 8 times faster than it should do. It'd be nice if it did run this fast, but foam cutting is not a fast process. So you can see in the previous section, getting the kerf value right, it makes a real nice cut. So we're just coming up to do the spar hole and back out, and then getting towards the end. And that's it. So what I'm going to do now, once we switch the wire off, is take the test piece out the foam block and then just lay it across the printout. And this printout was done with Dead Wing Foam 2. And what I'm going to do first of all is just check the spar hole. So it's 4mm. So I've got a 4mm drill here. Near enough. And we're just going to try that in a spar hole and see what it's like. And as you can see, that goes in really well. You know, it's almost a perfect fit. And then what we'll do now is we'll lay it over the drawing here. So with Dead Wing Foam 2, you can print these drawings off. And this is actual size. So we'll get the other camera on, just get you over the top so you can see. And as you can see, it's perfect to the naked eye. You know, I don't think for foam cutting you could get any closer than that. So, you know, if anyone says it's foam cutting with a machine like this is not accurate enough, you know, just have a look at this. So that's our test cut done, guys. And you can see it looks really well. It's got no stringing on the foam itself. So guys, that brings us to the end of the video. Hope it's been useful to you, and if you've been thinking about using the MKS board, you can see it's quite possible to use it. I quite like it. I think it makes a little bit of a neater installation when, especially using some of these 3D printed parts. You know, if you've got a 3D printer, you can make it quite a nice installation, and there's some useful parts you can use, like, you know, cable clamps and that type of thing. So for next year, what I'm going to try and focus on more is actually using the foam cutter. This year's been more focused on getting the software working well and doing videos on the foam cutter itself, you know, with the ramps and Arduino board. And it's proved very popular as well. You know, I've been surprised how many of you downloaded the plans, which thank you very much for that. You know, it does help to fund the website and buy these parts to do these videos. And you know, I've been blown away by, you know, the good comments I get. I do get one or two strange comments as well. I had a comment on the part 1 of this video series. The first comment I got was from a guy in Russia, and he said, speak Russian. I had to use Google Translate, and I wish I could speak Russian, but sorry, I can't. And if you do get any problems, you know, just drop me an email or a comment on YouTube. I had one strange comment from a guy who said that I never replied to his comments, or, you know, no response and nothing worked, which is totally untrue. I respond to every comment on all emails, as some of you probably will know. So, you know, if you do get problems, you know, do let me know, and I'll do my best to help out. And I think so far all the guys that have contacted me, we've managed to sort out whatever problems they were having. So for next year, what I'm planning to do is I'm probably going to do a video on software, because there's been 1 or 2 new bits of software to generate G-code for wings like this, and there's some free ones as well that look quite promising. So I'm probably going to look into them next year and do a video on that. But what I'm also planning on doing, some of you may have seen some of my earlier videos. I did a whole series on using DevFuzz Foam 2, and we built a a T45 Goshawk or the BAE Hawk. It came out really well, and I was quite pleased with the way it turned out. There's only one problem with it: the bloody thing didn't fly. It was I had some design issues with it. It came out smaller than I expected, and you know, that's a long story. I'll probably talk about that when we do the new one. So what I'm planning to do is build a bigger version, but do it in a slightly different way, and use the 3D printer to design the jet intakes. So that'll make the fuselage a lot simpler. So if you look on the original videos, I actually created the jet intakes in foam, and it looked all right, but I don't think they were big enough, and I'd got the fan in the wrong place and nozzle diameters wrong and all sorts of things with it. So I'm planning to do that next year, build it bigger, because I don't like failing on things. I think it did fly for about 20 seconds and then crashed. I'll link you to some videos on that as well if you want to have a laugh. The other thing I'm doing as well, I'm quite keen to build a forward swept wing. I've been working on the design for that, so hopefully next year we'll get one of them out. I've still got a wing to finish yet because of COVID and all that. I've not been able to fly. It's probably about 90% finished. It just wants a little bit finishing off, and it's going to have an iNav flight controller in it as well. So I like messing about with them things as well. So thanks very much for watching, guys. If you're watching this just before Christmas on 2020, have a good Christmas, and let's hope next year we can get back to some normal life and, you know, things get better. So catch you in the next video.